Can you hear me?
Yes, hocam.
Yeah.
Screen. I did an announcement on 13th of November, Friday at 5 p.m. We are planning to a short test quiz for you, Calculus 1 students. This quiz will have no percentage. That means you will not get any grade or mark. It is just to test whether everyone has both the course book and really has access to WebAssign for the actual exams. The topics, if you want, the topics are limits and continuity. So this from here questions will come. And this week, hopefully, we will create the WebAssign accounts for everyone, and we will tell students how they can log in their accounts. So this is the main page. So hopefully this week, everyone will be able to log into WebAssign system. But still, we are working on it. Okay, so this is the plan. So this will be a test quiz. So this is not real. So with this one, we will see if you have problems beforehand. So you will be well prepared for the real assignments. So this is our aim. It's like demo. This is like, you understand? Test. Okay. So everyone, I hope is okay what I mean with the test. Like you are testing yourself. Okay? Okay. Can you hear me?
Yes, hocam.
Okay, my connection went for a while, but there's good news that I am back. Okay, so actually we haven't started yet, but yeah. Okay, guys, so I did my announcement. I opened the attendance also. Here, where is the attendance? This is in here. Okay, so that's all. Let's start our lesson, okay? Can you see the PowerPoint?
Yes.
Okay. Now we are starting chain rule. Last time we see how to calculate derivative of the functions. This will, but we have some new process now. We will deal how to calculate the derivative of composition of functions. What is the trick? How can we manage this? So the chain rule is about this process. Okay, so what is going on with chain rule? Let me explain you. So if y is f of u, where u is a differentiable function, okay, so that means that this is actually a composition of two functions. But so the u is g of x is a differentiable function of x, then y is equals to f of g of x is also a differentiable function of x, so you can take its derivative. So how you do this? Now, can you see that y is a function of u, and you are taking the derivative of this y with respect to x. So what you do in here, what is this formula says? This is equals to derivative of y with respect to u times derivative of u with respect to x, or equivalently, derivative of this composition is f prime of g of x times g prime x. So here, f is outside function, g is inside function. So you can read this like that also. Derivative of outside function, okay, you apply to the inside function times derivative of inside function. Now, I will do examples and you will practice this theorem. It is very easy. Once you understand, you will do this process very easily. Now, let's keep on. So the book gives more explanation. But I said, he is also telling here, when applying the chain rule, it is helpful to think of the composite function, so f with g, as having two parts. An inner part, see this one, inner part, and outer part. So outer function or outside function, inside or inner function. The derivative of y is equals to f of u is the derivative of outer function at the inner function u times the derivative of the inner function. Yeah, y prime is equals to f prime of u times u prime. So in here, just practice, just warming. So how you should think given functions in terms of u. So what we are doing actually, you are saying the inside function u, and then you rewrite your function as y is equals to f of u. So you are making actually firstly your function, changing your function in a more simple form. Like here, for example, y is equals to 1 over x plus 1. This is a composite function. Here we say u for g of x. So g of x is actually in here what? X plus 1. So this is your u. Then y turns to what? 1 over u. Because later on it will be important, because now this function has more simple form than this. Okay, but it's written in terms of u. For example, look at the b1. Y is equals to sine 2x. Now, how we can rewrite this in a more simple form? We say that this part is u, so 2x is u, so you write y is equals to sine u. So far, we don't know how to calculate derivative of sine 2x, but we know the derivative of sine x. So with writing this u, then you can use the rules that you learn, but when you are doing, you also do something for this u. So I will explain in more detail. Here again, y is given with a, can you see, complicated function. You say this, so but your aim is actually to write it in a simple form. So this part is u, and then see this just turned to a square root of u. Then you will take the derivative of this using the formula I just explained in the previous PowerPoint. Now, so this one again, tan square x, u is here tan x, then y turns to u to the power 2. So, general power rule, this is important, and we will solve lots of questions according to this. So, okay, let me check again the class. We are recording, everyone can hear me. Okay. Now, the function y is equals to n power of u of x is one of the most common types of composite functions. The rule for differentiating such functions is called the general power rule, and it's a special case of the chain rule. Now, so it just explains the general power rule. So this just gives you how you can use the chain rule if your the function y is in this form. So when your function y is in this form, so n power of u of x, where u is a differentiable function of x and n is a rational number, then derivative of y with respect to x is equals to n times n minus 1 power of u to the power x times derivative of u with respect to x, or equivalently just you can write that like that. So n times u to the power n minus 1 times u prime. So instead of this notation, you can write the notation with the prime. So how we can practice this? You are wondering, because I tell you lots of abstract, you are thinking, what are these? Now it's the time to exercise. It's time to use this knowledge. How we will use this knowledge? What is u? What is this derivatives here in our case? Now, so it is asking you what? Derivative of f of x. F of x is given what? Cube of what? 3x minus 2 times x to the power 2. Now, this is actually a composite function. In here, we will use the general power rule. Now, sometimes you can replace this of f of x given is like this guy, the cube of this guy. You can also write this as y is equals to cube of 3x minus 2x squared. So here, y is equals to this guy. Now, what you are doing, you have actually outside and inside function here. The outside function is taking the cube. Whatever you have, you take the cube. So inside function is this one. So for this inside function, you say u. Okay? So then this turns to what? Y is equals to u to the power 3. Where u is this guy. And then you apply this rule. So u is the inside. Where the x guys. In here, this is constant. So whatever here, you take cube. So u is this one. Then, as I told you, this turns to this form. Can you see that? This was very complicated. Now, this is just a function u to the power 3. Now, from the rule, this one, what we will do now, we will use the theorem. How we will take the derivative of now f prime x? Now, so you are using this one, or you can do this one. So you first, you are just taking derivative of, this is like, now because it is u to the power 3, how we should take the derivative of, what is the derivative of u to the power 3? So just the variable is here, u. What is the derivative of u to the power 3? Or last time we learned what? Sorry?
3u square.
3 times u to the power 2. Am I right?
Yes.
But now this is not the answer because u is a function of x, so we should continue. You need to multiply also the derivative of u, whatever you write. Now, what you are doing here, basically, you are just taking the derivative of, is just using the power rule. So 3 comes before, then what happens? This guy to the power what? 2. So u to the power 2 times derivative of inside function. What is the derivative of inside function? So this one's derivative of the inside function. Here, then the answer comes as 3 times this one times, what is the derivative of this? 3 minus 4x. So this is the answer. Did you see what I did here? So if you want to use with the u, so u, this is u to the power 3. What is the rule says? And what is n3? 3 comes to the front. Then u to the power n minus 1. What is n3? That means u to the power n minus 1 is what? 3x minus 2x squared to the power 2. Times what? Times du dx. Which means u prime. Or you can think like that. Derivative of, firstly you do the derivative of outside function, okay, power function 3, then whatever inside you just copy, you decrease 3 with 1 and then times derivative of inside function. Do you have any question with this example?
Oh, no.
Okay, let's keep on. Look at this. Find the derivative of this guy. Okay, now you are asking what is the connection with chain rule? It will come back. It will come. Now remember we had product rule. So you have two functions here, h and g. Okay. Now I rewrite this in this form. Now this is h, this is g. We will use this formula. So h is this, h times derivative of g. So h times derivative of g plus g times g is this times derivative of h. Okay, derivative of h. Now x square is x square. Now at that moment we need chain rule, because we can only calculate the derivative of this guy with chain rule. Now this is again power rule, isn't it? You are taking power 1 over 2 power of what? 1 minus x to the power 2. What you will do here, you will take the derivative of this one. How you will take? You will just take 1 over to the front. You will not do anything with this guy. You just write, and the power decrease with 1. So 1 over 2 minus 1 gives you minus 1 over 2 times derivative of inside. What is the derivative of inside? Minus 2x. So with this we calculate the derivative of this guy with chain rule. Then we keep on with this. So I just keep writing this as it is. That is the derivative of this what? 2x. If you continue with this, if you do the simplifications, you will get this expression. This is just exercise. In here, and at the end you will get this. In here, the very important part is this. Are you okay how I take the derivative of this? Did you understand? So this part with the with the parentheses tells you the derivative of this one. Do you have any question about this? Same thing we did here. Remember, in the first example, 3 was the power, right? This was the inside function. We take 3 the front, and we just write this as it is and decrease the power with 1 and take the derivative of this one. Now, similar thing, power comes to the front, you don't touch this and decrease these guys with 1 and then take the derivative of inside. Do you have a question? These parts are just calculations. You multiple with minus x to the power 3 with 1 and this with and so on. But did you understand how I calculate this? Do you have any question?
No.
Okay. Now have a look at this. You have a function. Remember last lesson we learned the quotient rule. Now, but before starting these operations, so using this quotient rule, you need to rewrite this in this form. Okay, now h is this guy, h is this numerator, g is the numerator. Use the formula. What was it saying? Denominator, denominator times derivative of h was numerator, derivative of x is what? 1. Okay, minus, so you put minus from the formula, we write this minus. Keep on, h, what is h? H is this one, x, see x times, now derivative of what? G, this is g. Now again, can you see that? You are now using chain rule. Power, isn't it? Using the power rule for chain rule. Now this is a composite function. You have a power, right? 1 over 3 power of whatever you have. This is the outside function, and inside function you have this x squared plus 4. Now, what we will do here, we take this part to the front. You don't touch anything with this. You write, you decrease this power with 1. 1 over 3 minus 1 gives you minus 2 over 3 times derivative of inside, 2x. Did you understand the derivative of this? The similar thing just we did in the previous 2 pages. The similar process. You okay with this? Anyone has question?
No.
Okay. Now we should continue g square. So g was this. So if you square this will be this guy to the power 2 over 3. After that, you just keep on the calculations here. Just this part is calculations. So x squared plus 4. Here also x squared plus 4. Okay. Now, so this is a common denominator. If you divide this one with this one, you will get this guy. Okay, in here. Oh, okay. In here, actually, sorry, I didn't see that. Here, you are also doing. Okay, you are taking 1 over 3 to the front. Okay, you are taking this. Yeah, common factorization is happening here. So this is x squared plus 4 to the power minus 2 over 3 times 3 times x squared plus 4 minus 2x squared times 1 over x squared plus 4 to the power 3. Okay, so denominator doesn't change. Just this part is rewriting. Okay. Yeah, just this part is rewriting. This is just calculation part. Here again, this part is very important. Derivative of this is this guy. 1 over 3 times this one to the power minus 2 over 3 times 2x. And then you can simplify and get the final answer. Okay. And again, do you have any problem with this calculation?
Are we going to use this formula when we see rational number?
No, this is general. This is general. You mean the chain rule? Yeah, see, this is not rational, but we use the chain rule. Okay, I understand. Okay, if they are asking to find the derivative of a function like that this is not rational, but it's a fraction. Okay,
Yes,
you have
fraction.
numerator and denominator. I understand your question. Yeah. Then you should use formula, yes.
Okay, thank you.
Yani, I understand your question. With the formula, you are telling me this one. I am now showing. Yes, if you have fraction like numerator and denominator. Yani mostly yes. Sometimes you may do some tricks, but when you are doing, at some point, you need to calculate the derivative of an expression which is a composition of two functions, and you use the chain rule. Okay. Yeah, I understand your question. But yeah. Of course, but in here, for example, we use the product rule because there were two functions in the product form. We did lots of practice in the previous PowerPoint also in the previous classes. If you want, you can see more details. Okay, I uploaded the Moodle as well. Okay. Okay. Now look at this one. See again, my friend. This is like you have an expression here. We will see that in which part we will use this formula. Now, this is again a power rule we are using here. See the square of the outside function, square function. Whatever you have, you take the square. Now, we are using this one. derivative of outside function apply the inside times derivative of inside. So, okay, before starting, who has an idea? What will be here? Just don't tell me the final answer, but how I will start with taking derivative of this y? What I will write first here? So we are using chain rule. What I will write here firstly?
X square plus 3.
No. I mean this one.
We'll put 2 into of them, sir. So it will be 2 times.
Yes.
3x minus 1 over x squared plus 3.
To the power 1, right?
Yes.
Times?
Times 3 over 2 times x.
No. Times derivative of inside function.
Yes.
Okay. Thank you. Yes.
So it will be that, so 3 over 2 times x.
Yeah. So your friend just said what is written here. 2 comes to the front. This guy you rewrite, but you decrease the power. And then derivative of inside. Everyone okay? Anyone didn't understand? Please tell me. This is very important. Please tell me if you don't understand. It's the best. Now in the class, it's the best to learn. And lots of questions are coming in the exams, in the assignments, in the midterms, and so on. So please tell me if you have question about this chain rule, especially when we are using with the power rule.
Sorry, can you repeat it again?
Here again, see what we are doing. This is power rule. We are using power rule. So this is u to the power 2. Am I right? If this is u, y is equals to what? Y to the power 2. How we were taking derivative? Now 2 comes to the front. Then u to the power n minus 1. N is what? 2 times derivative of u. Or you can think like that. So you first take the derivative of this power function. So 2 comes here. You don't touch the inside. Decrease the degree with 1. 2 minus 1 is 1. And then derivative of inside function. What is it? Inside is this. But we haven't started calculations yet. But this is what you need to do. You okay with this?
Yeah,
Okay.
thank you.
Okay. So this is the 4th example. We are doing the same things, but with different guys. Again, see in here, the power was 2, the inside was this. So here, the power was 1 over 3, inside was this. Again, quick summary. Here, power was 1 over 2, but inside was this. In the first one, power was 3, the inside was this. But all the time we are doing the same. Did you understand? In these 4 examples, we did the similar things. Take the power first, decrease the so don't touch the inside, decrease the degree with 1 times derivative of inside. In the first example, we did this. In here, take the power 1 over to the front. So where is this? Yeah. Don't touch the inside, decrease this with 1 over 2 minus c, and take the derivative of inside. In the last one, in this one, how we take this? Take the 1 over 3 to the front, don't touch inside, decrease this with 1, and 10 times derivative of inside. And here now we are doing the similar process.
But sir, I think we didn't take the derivative of the second one. Like 3x minus 1 over x squared plus 3 will be derivative of 3 over 2x.
No, we will, now we have it, but we are just showing that what we will do. Now we are starting. Okay? You understand? Now we are starting.
I'm gonna use quotient rule. Okay. I did like just simple derivative. Sorry. Okay.
Okay. Yeah. I hope you. Now we are starting. So this is our plan. What we will do. This is now. You copy these guys and then take derivative. But when you are taking derivative of this since has a fraction, numerator and denominator, you will use this form, quotient rule. So h is this, g is this one. So g times g is this times h prime. H, what is the derivative of 3x minus 1? 3 minus c minus formula. Now h is what? H is, where are you? H was this one, 3x minus 1 times derivative of g. Derivative of x squared plus 3 is what? 2x over derivative, sorry, not derivative, square of what? G, this one. See, in here we use the quotient rule. So when you are using chain rule, you may use product rule, you may use quotient rule. So you are using lots of rules together. You are doing a combinations. So the questions are coming more challenging. But once you know what to do, it's okay. You should first decide what to do. So this is chain rule. It's a power rule. Apply power rule. Okay. When you are applying power rule, at that point you need to take derivative of this. Okay. How I will take derivative? I am looking. Oh, this is a fraction. Okay. Then use this rule. Okay. So first decide what to do and what formula I can use. Can I use product rule? Can I use quotient rule? Quotient for fractions, right? Product rule for when the function is in the product form. That's it. And then just the calculations parts here. Again, now here x squared plus 3 to the power 2 and times this one gives you the cube of this. So this time this gives you this. So 2 times 3x minus, okay, times, and then 3 comes to the here, 3x squared plus 9 minus, then c minus 3x times 2x gives you this one. And then minus times minus 1 times 2x gives you this. And if you keep on this, sorry, so this one also gives you what? 3x squared minus 6 squared is what? Minus 3x squared and so on. So you finish at that point. Okay, so we did 5 examples so far. Do you have any question about the chain rule and also the main questions? You okay? Okay?
Yes,
okay.
yes.
Yes, perfect. Now, what happens if we are playing with trigonometric functions? How we will use the chain rule? So in here, this time, what happens if you have like because everyone knows in the class what is the derivative of sine x? It's cos x. Am I right? We learned this. But what happens if you have like sine 2x, sine 3x, sine of x squared plus 1, and so on? Then how we will calculate this? So what you are doing this time? So you are sine of whatever. So it's not. So in this kind of questions, you don't have x, but sine of something, a function in terms of x. So you say u for this expression, and the derivative of sine u is what? Derivative of outside function. What is it? Cos u times derivative of inside. Like for tan u, what is the derivative of tan u? Secant square u times derivative of inside. Similarly, derivative of secant u with respect to u times derivative of inside. Here, derivative of this guy with respect to u first, and then times derivative of inside. Derivative of this one with respect to u times derivative of inside. Derivative of this with respect to u times derivative of inside. The insides are these u guys. Again, similarly, okay, so we are using this. Here, f is the outside ones, g is the u ones. Okay, let's practice. Look at here. See, sine 2x. We haven't seen this before, but this is composition. So f is what? Sine function. 2x is the inside function. So how we are calculating this sine u? derivative of our sine function, right? Cos 2x. You don't touch to 2 times what? So, or you can think like that. So this is sine u, okay? What is the derivative of sine u with respect to u? Cos u, which is cos 2x times derivative of inside of 2x. What is this? Cos 2x times 2 is equals to what? 2 cos 2x. So basically, derivative of outside function, don't touch the inside, cos 2x times derivative of inside. See, from here to here, you can jump very quickly. Derivative of outside, cos 2x times derivative of inside, 2. But when you are using this derivative of outside, applying the inside function. Do you understand here? So, for example, I want to ask you, if this was not 2x but 3x, what you will write? Sine 3x, for example, what is the derivative? What will be this solution?
3 cos 3x.
No, not 3x. If this was sine 3x, what is the derivative of sine 3x?
Cosine 3x times
3x.
Okay, cosine 3x times what?
3.
Yes,
3.
exactly. Yeah, exactly. You understand the idea? Okay.
Yes.
See this one, cos x minus 1. Derivative of outside minus sine of this one, you don't touch. Derivative of inside. My derivative of inside is what? 1. 1 here is here hidden. Or you can say, okay, you can use the this formula if you want. Minus times sine u times u prime. Minus times sine u times u prime. U is this. So minus times sine u is x minus 1, yes, times u prime. That's it. Do you have question with this? You
No.
okay? Okay. How about this one? This is very easy. So what you do here, you copy this and then take the derivative of this one. You copy this, take the times derivative of this one, which is 3 times e to the power 3x. So e to the power u times u prime. Okay?
Yes, doctor.
Okay. Derivative of natural logarithmic functions. We will come to this point, but I need to tell some information about logarithmic functions. Now we will see this ln and so on, but we have some properties and so on. So I want to tell you about this. So we have logarithmic functions. I will upload this also. This is from another source. Recall from algebra that a logarithm is an exponent. So b is bigger than 0 and b is not equals to 1. Then this expression is read as the logarithm to the base b of x. Denotes the exponent to which b must be raised to produce x. So what is the logarithm does actually? So here, for example, one guy asks you logarithm 10 to the power 100. What does this mean? It is asking you what powers on 10 gives 100? 2. Do you understand? This is the idea. So here, logarithm 10 to the power 100 means that what power of 10 gives you 100? Of course, 2. So this is the idea. So here, for example, what powers of 2 gives you 16? 4. Because 2 to the power 4 is 16. And so on. Roughly, this is what logarithm functions do. There are some technical here. I don't want to go on with this. what you need to know for these ln functions, so this is logarithmic functions, okay? I will come back to this. What we will do, we will interest with ln function firstly, okay? In the slide shows, because it firstly tells you the ln, the book says the ln. So the ln x actually a special type of logarithmic function, but in this book it explains in another way. So let x be a positive real number. The natural logarithmic function denoted by ln x, and defines is like that. Ln x is equals to b if and only if e to the power b is equals to x. Actually, in the ln x, your basement is always e. So basically, in here, if you choose b as e, then logarithmic b to the power x is ln x. Okay? Now, we have some properties. Ln 1 is 0, because e to the power 0 is 1. Ln e is 1, because e to the power 1 is e. And ln a to the power minus 1 is minus 1. Here, domain of ln is 0 to the infinity. This is important. Ln e to the power x is equals to x. E to the power ln x is equals to x. This informations sometimes we are using. Here the main properties. Let's x, y, z real number such that x is bigger than 0, y is bigger than 0. So we have these properties. Ln x, y is equals to ln x plus ln y. Ln x over y is equals to ln x minus ln y. And ln x to the power z is equals to z times ln x. Sometimes you are using this property. So for example, look at here. Ln 10 over 9. So you are using this one. This means that ln 10 minus ln 9. Here, for example, ln of this, you can rewrite this like ln of 3x plus 3x plus 2 to the power 1 over 2. So this rule says that you can take this power to the front. So this is equals to saying that this is equals to 1 over 2 times ln of 3x plus 2. This one, for example. But my friends, we are not doing derivative, okay? I'm just explaining you the properties of ln. Here, for example, this one. Quotient, right? Ln 6x minus ln 5. And here is product. You can write this like that. Ln 6 plus ln x minus ln 5, and so on. Okay?
Mister?
Yes.
We need to study this also?
Yes, you need to know this. You need to know this. And this is for that reason I give you this PDF. Also, when you can also have the information. We are using these rules. So these ones. So these properties you need to know.
Okay.
Yeah, these properties. So these are like tools. Sometimes you are using this property. For example, they ask you the derivative of this one. So you first rewrite this and take derivative. For example, so these are our tools. Okay, handful tools to rewrite this ln function is in a more simple form. Then you can take derivative more easily. This is quite this example 6 is quite technical. So this example 5 is important to understand the rules. This is properties. These two guys also we use. This one's important. This ln 1 is 0. We will use a lot. ln 1 is 0. ln e is 1. We will use a lot these two guys. We will use this one a lot. Let me highlight this one also. So these properties we will use a lot. Okay. Sometimes we will use these ones also. This is important. Domain is very important. This is ln x, graph of ln x. See, if this part is not defined, this part only, because the domain is starting from 0. Okay. 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 Now what we are doing? So here it explains you the derivative of ln x. The derivative of ln x is 1 over x, okay? X is bigger than 0 because I told you that ln function is defined from open interval from 0 to the infinity. This is the reason is written like that here. What happens if you are chain rule situation? That means what happens if this is not x, ln of u is a function. You are using chain rule. The formula is this: 1 over u times derivative of u. So this is basically u prime over u. Now, for example, look at this. Okay, we have 2 minutes. What is the derivative of this? So what is u here? U is 2x, right? Am I right? U is what? 2x. So this is ln u. What is the derivative? U prime over u. U prime over u. U prime is what? 2. U is what? 2x. So the answer is what? 2 over 2x or 1 over x. Are you okay with this?
Yes.
Sorry. Now here, what is u? This one. What is the answer? U prime over u. What is u prime? 2x. What is u? X squared plus 1. So this is the answer. You okay?
Yes.
Okay. Let's check. Here, for example, x times ln x. Now you need to use product rule firstly. X times derivative of ln x plus ln x times derivative of x. X times 1 over x plus ln x times 1. That's it. Any questions? If not, I am finishing this part. Do you have questions? Let's give break. Okay?
Okay.